Okay, let's do the 10th question, that is limit of this function when z is approaching 1. Okay, so as z is approaching 1, it is very close to 1, so that we can assume z to be 1, and when we apply that the value of z, that is 1, we get 1 raised to 1 by 3, which is 1 minus 1, and here also we have 1 raised to 1 by 6, which is 1 minus 1, which will be 0 upon 0, which is indeterminate form. So we have to change the form of this function. Okay, use some other technique so to solve it. Now, so let's discard this, and now if you check at this, now if you look at this resembles a property or a theorem, that is limit of x raised to n minus a raised to n whole divided by x minus a, where x tends to a, which will be equal to n multiplied by a raised to n minus 1. Okay, now if you look, this almost resembles this theorem, but the only thing is we have in the denominator we have z raised to 1 by 6 minus 1. Okay, so to change this we use some the techniques and problem procedure. Okay, just watch. Now we'll write this as, now what we do is we will divide the numerator and the denominator by z minus 1. Okay, so limit z raised to 1 by 3 minus 1 whole divided by, we'll divide by z minus 1, and whole divided by the new denominator z raised to 1 by 6 minus 1 divided by z minus 1. Okay, so limit z tends to 1. Now we are dividing both the numerator and denominator by z minus 1. Okay, now again we have a property, that is f of x by g of x, f of x by g of x, and limit x tends to a, then this form can be, the limit can be split both to the numerator and denominator. Okay, that is, and we can write this as limit x tends to a f of x whole divided by limit x tends to a g of x. Okay, now the limit can be split to both the numerator and denominator, so we can write this in this form. So this is exactly in this form. Okay, so let's split and write. So we write it as limit of z tends to 1 is z 1 raised z raised to 1 by 3 minus 1 by z minus 1 whole divided by z raised to 1 by 6 minus 1 by z minus 1, limit this function as z tends to 1. Okay, now this both has become separate functions. Now see, this resembles this. Now if you see, this resembles this theorem, so we can write this in this form, okay, so it will be 1 by 3, that is n multiplied a raised to n minus 1. Okay, so 1 by 3. Now this here, if we have 1 by 3, and here we can write 1 by 6, because 1 raised to anything is 1. So 1 by 3 multiplied by 1 raised to 1 by 3 minus 1 whole divided by the denominator part 1 by 6, 1 multiplied by 1 raised to 1 by 6 minus 1. Now 1 raised to anything is 1, so this will become 1 by 3 upon 1 by 6, which can again be written as 1 by 3 into 6 by 1. So this is 3 2 times, so we have 2. So this is the answer. Okay, now let's do the 11th question. Okay, that is limit of this function where x tends to 1, okay, where x is approaching 1, and the condition is given a plus b plus c is not equal to 0, okay, so that the denominator should not become 0 a b c, so that it may become undefined, okay. So now applying the value of 1, we'll see, okay, a, so it becomes a multiplied by 1 raised to 2 plus b multiplied 1 by 1 plus c all divided by c 1 square plus b multiplied by 1 plus a. Now this also again it can be written as a plus b plus c, okay, all divided by c plus b plus a. Now this both get cancelled out, so you get 1, okay, that's it.